Okay, good morning, good evening, or good afternoon, wherever you're from. I'd like to welcome you to this webinar, and this is coming from the School of Mechanical and Manufacturing Engineering within the Faculty of Engineering and Computing in Dublin City University. And today I'm going to present the master's programs in engineering, in mechanical engineering in DCU. Um, so a lot of people are really interested in jobs or opportunities in the master's program, but the real reason why you might be here really is well, it's up to you. But certainly from my point of view, we get lots of students really wanting to upgrade their career. They want to engage with new opportunities. We've students coming into different parts of our master's programs from sustainability, from biomedical, from engineering, and really wanting to engage with different things. Maybe engage with opportunities around sustainability, maybe engage with new developments in manufacturing. But ultimately, in a way, some of you and most of you want to kind of progress, get amazing career options, and do some good in the world. And from our perspective, here in DCU, what we're certainly seeing from the workforce and certainly the employers is that engineers are wanted, and not only just qualified engineers at degree level, but certainly master's level graduates are required. And this is just showing that the changing world of manufacturing, design, development within our world in relation to a degree holder has a certain capability and ability. But what we do with our master's programs, we bring them to the next level and we really engage them with what's going on in the world, really challenge them in the defined major they choose, whether it's sustainability, manufacturing, biomedical, etc. And we also focus our students on activities around around topics around what actually our employers are actually teaching or actually want to see in their workforce. So today I'm going to go through the master's course, and there's a couple of options of how to get onto the course, and also a number of choices you can as a student within the course to decide what type of master's qualification you come out with. So I'll spend the next 15-20 minutes around this, and please put questions into chat. I'm happy to answer them as I go along, or actually I can answer them at the end either. So I want this as a kind of an engagement activity with you. So myself, I'm the program chair, and my name is James Carton, and I have a PhD in mechanical manufacturing engineering. My specialization is sustainability, and my deputy chair is Tomas Shi. And both of us engage with students right throughout the year from now, where students are kind of filling in the forms and kind of applying. We assist students to kind of, if they're eligible for the course, and then obviously once they got onto the course, we ensure that their stay in DCU is um, is content, they're content, and any challenges that students come along, we engage with. And we again within the activities, if there's questions around fees or anything like that, we point you in the right direction. If there's challenges with registry, we help you. And again, if we point you in the right direction in relation to support and activities as well. Um, so as program chairs, we design, we develop the program structure, and this program structure is constantly evolving. But this is the structure I'm going to be discussing today, with a new addition which I'll discuss later on. And so basically, what DCU basically has is a mechanical and manufacturing engineering master's program, and within that, um, the we require students to have the right level of pre-qualification. And so this kind of develops this table in relation to what we expect. So we expect students within their degrees to have a mechanical or manufacturing engineering degree. And if it's on the high level, uh, um, we accept them directly onto the course. And that's kind of automated. A number of those applications come through myself or Tomas. Um, but effectively that's kind of straightforward for many students. If students have a mechanical and manufacturing or manufacturing engineering degree, but unfortunately have a lower level, maybe H3 or below, then we would suggest that maybe those students need to work a bit harder to actually have the ability, certainly in maths, in fluid dynamics, etc., to actually be able to pass the master's program. So what we'd say was we'd bring them in on a qualifier course, and a qualifier course is a year-long course that students do, and then once they complete that, the year after they can apply then for the master's program. If a student comes to us with a science or technology degree, we usually assess them either pre-application if the students send us details, or during the application process where we engage with registry around CVs, around transcripts, etc. And again, we decide whether if their technology degree has the maths, has the thermofluid skills and those aspects of engineering. And if they do, we can actually allow them straight onto the master's. We can suggest the qualifier course, or we suggest the access course. And the access course is a little bit different than the qualifier course. This is, again, a year-long program. And this allows the students to actually gain a lot more knowledge than they would have, because they wouldn't have had the basis of mechanical engineering. So a lot more in fluids, a lot more materials, a lot more maths, and that ability to use that in the learning stage of actually being able to qualify then for the master's program complete the year after. And so once you get into the master's program, you then have a choice that you can pick a major, and I'll go on to them in a minute. And then we have a number of exit awards. So if students don't get the full 90 credits of the master's program, they can come out with exit awards as well. So I'll be coming back to this structure throughout the slides, and just for clarity. So the majors we have, and this is up to the students. Students apply for the master's program, and then within the first week, they, as they're registering, they choose the modules they like, they want, and they want to suit their career and their advanced training and education. So we have simulation-driven design, advanced manufacturing, biomedical engineering, sustainable systems, and energy. And those are the four majors that people can choose. Now, if it's and those majors are connected to specific modules. So if you have all those modules, you automatically become out with that major. But some students pick and mix multiple modules that may not align with any of these, and that's okay. Students can do that. And if students come out or do that mix that don't really suit every major, they still come out with a master's in mechanical and manufacturing engineering. So, for example, if I chose modules that suited the biomedical engineering, and my project was a biomedical engineering project, therefore I would come out with a master's in engineering and mechanical and manufacturing engineering with a major in biomedical engineering. So it's a mouthful, but certainly it really just shows the employer that you are an expert at master's level in biomedical engineering, for example. If I didn't choose a major, I'd have a master's in mechanical manufacturing engineering. If I chose sustainability, I'd have a master's in mechanical manufacturing engineering with a major in sustainable systems and energy. So again, it's a way maybe potentially within your area that you're interested in somewhere that you want to work. Is a general engineering master's applicable or useful, or would a major suit? And again, on your own preference, which modules do you think might be more interesting for you? Which ones you like, and obviously which ones might you pass? So I'm going to go in through kind of the modules now, and again, just gets you an insight into types of modules. I'm not going to go in depth in the modules, but I can answer questions if you have questions on particular modules. But the titles we think are actually quite useful, so we'll go through these. So on the left, we have the codes of the module, and so you don't really need to know much about the codes at this stage, but certainly the title then is in the middle, and the credit is on the right. So all our master's modules are all credited at 7.5 credits. So that's 187 and a half hours of work that each of these modules require, whether that's in class, whether it's assessment, whether that's study, etc. So that's the amount of time for these modules. So they do take up a lot of time if you are to get a good mark. So in all our modules, or in all our programs, we have our research practice methodology. That's a kind of a core element. So that's taught across all the majors for master's programs. And this this is kind of everyone takes that module for whatever, even if you have whatever major you choose. It's a research practice methodology. It allows students to understand data, manipulate data, understand the research capability, and have ability to actually develop methodologies, etc., around engineering, around experiments, etc. So I think it's a really, really good module and really useful for projects as well. We then go into the modules. We have finite element analysis, heat and mass transfer, energy management and economic analysis, surface engineering and tribology, manufacturing systems and simulation, energy system decarbonization, and energy auditing and energy management. And as you can see, actually, a lot of these modules you can link in with kind of the ones that would align with the majors, sustainability, manufacturing, and then the finite element analysis crossover biomedical and engineering. So then in semester 2, we go into more advanced ones. So advanced finite element analysis, computational fluid dynamics, manufacturing processes, entrepreneur for engineers, advanced sustainable energy systems, whole life cycle analysis, turbo machinery, global sustainable development challenges. And again, the idea here is that the amount of modules here are obviously you don't do all these modules, and you have a choice. And again, if you choose a different major, you would choose the ones biased to that over the ones for another one. So these are all, so basically when you go to register, you will actually have a list and you will choose the ones you like, or you'll choose the major, which one then will automatically choose the modules that you need. So what I'd like to, so then on some of these there's prerequisites. So you can't just choose some of the ones that need prerequisites. You can't just choose them in semester 2. You have to actually choose its prerequisite in semester 1, so that you can actually choose it in semester 2. But within the registry process, it's kind of automated, so you don't make any mistakes. But just be careful when you do know that there is prerequisites for some of the modules. And then we've also got the advanced biomechanics and tissue engineering and design and clinical practice. And these are actually happen for the biomedical. These happen to be year-long modules. But again, you can get the mix then of you would do these year-long, and you would do additional modules to get the biomedical engineering major if that was what you wanted to do. So what I want to do here then is just talk about, in addition to those modules, so you'll choose the modules that suit you there, worth 60 credits. So if you imagine 7.5 credits each, 60 credits, and that's the modules you choose. The other 30 credits to get a 90 credit master's qualification is your project. And your project effectively is effectively a year-long project where you really develop your project from scratch right up to a very big presentation, conference day, thesis, conference paper, etc. So it's a lot of work in it, and it's 30 credits, so we expect a lot of detail, advanced engineering in it. And again, depending on your major, if you choose a biomedical major, well, your project's going to have to be a project in biomedical engineering. if you choose a advanced manufacturing major, your project will have to be in advanced manufacturing. If you choose a general degree without a major, well, actually, you have a choice in maybe diversifying your degree by actually choosing any type of project you want. So we've had students that had kind of maybe biased some of their modules with biomedical, but they've done their project on sustainable, and then you get a master's degree, but you don't get a major, but you have this mix of two areas to help design develop your abilities. Um, and again, I can talk more on the projects, but and again, these are supervised by the mechanical engineering lectures. We've got advanced research centers in mechanical engineering, advanced manufacturing, biomedical, sustainability, and again, the projects will be based around the research that's happening in DCU, which is world class. So if I'm going to go in, so again, I've told you there's a lot of modules, there's a lot of projects, and again, from your perspective, you don't choose all those modules, you choose a selection. So I'll give you an example here from this section. Then is basically if I'm choosing a certain major, what kind of modules do I choose, and how does that work? So I'm going to go for each of these one at a time. So bear with me. Okay, so no matter what you do, um, whatever major you take, you have a project which is worth 30 credits, and you also have research, practice, and methodology. So that's 37.5 credits, and then you need the rest of the credits to get the 90 credits of modules. So this is an example of a major in simulation driven design. So you have your research, practice, and methodology, and you have your project at the end. And then the modules that you definitely need to have are manufacturing system simulation, turbo machinery, advanced FEA, computational fluid dynamics. And then in addition to that, you need 3 more credits then to get the full 90 credits. So you can choose any other three modules. So that's the way the system works. So you definitely choose these ones, and then you choose any others. So we've got students coming in and saying, I've got these, now I need to maybe a little bit more information on maybe entrepreneurship or sustainability to kind of tie in with what they're doing. Or they have an interest in um, some other modules that they like. So again, it's that um, flexibility that we allow students to have in relation to getting a major in a very specific area, but certainly adding on maybe stuff that they like as well onto it, so that they can get the best out of the degree that they can. When we go into major in advanced manufacturing, as normal, we have research, practice, and methodology. We have the project, but now we've got engineering management, economic analysis, surface engineering, manufacturing systems, advanced processes. So again, that ties in very well with the advanced manufacturing. And then for this major, you choose 4 other modules to get up to the 7 point or the 90 credit limit. And again, for here, again, the flexibility of actually getting this major with these types of modules, but also then you 4 other modules in anywhere you want is very very appealing to students as well. And if we go into sustainable systems, we've lots of modules here. And so basically we have our core module of research, practice, and methodology. We have project in sustainable systems energy. And then basically you would choose 4 of the modules from here. So energy system decarbonization, energy auditing and energy management, advanced sustainable energy systems, whole life cycle analysis, global sustainable development challenges. So you could choose 4 of those, or you can choose all of those, and so 4 of those, or 3 others, or all of those, and 2 others, I think. So again, students, then you can see that really from your CV perspective, if you get the major in sustainable systems and energy, you really have covered a lot of different areas, a lot of capability in that area. And again, from an employer perspective, you really can see that you have a master's coming out of Dublin City University with these modules will be very, very valuable. And the biomedical engineering, then we come in again, the research practice and methodology, and again, the project in biomedical engineering. And then also then we've got the advanced biomedical tissue engineering, design for clinical practice, advanced FEA, and computational fluid dynamics, and then select any other three others basically. So again, the ability for your major to be very defined in that area, students really love that, and then also employers love that as well if that's the area that you're definitely going to go into. So for most of you, you will be doing full time, and so basically we start off in semester one in September. We usually have around 30 credits of modules, and then semester two you have 30 credits of modules, and then we generally give you ideas around the project in September, October, but from this year on, we're going to basically kick off the project in earnest, we'll say from January right through to summer. And again, we feel that students really can concentrate on their modules in semester one into semester two, then their project into semester two and over the summer. And again, the year-long masters ends in September actually, or end of August. So it's a year-long program. It's a 12-month program with over the summer no modules, but you do your project. So part-time ends up being kind of similar a little bit, but broken in obviously to 2 years. We'd suggest if students doing part-time, they do 2 credits per semester per year, and then they would effectively do their project on the second year rather than the first year. But it's up to the student to do that. And again, we're very applicable to part-time students and supporting the idea that students do work and do study at the same time. And we also have capability in some of the modules for blended learning. Some of the activities, tutorials can be online, some of them recorded, and then a lot of the stuff is on campus. So again, we work with students to kind of ensure that they can have the best access to what we're teaching them that is possible. So I want to talk about exit awards. So obviously you're coming in here to do a master's and we want you to exit with a master's. So basically the idea is that you have 8 modules at 7.5 credit, level 9 modules and your project. So you come out with 90 credits and you get a master's in the major in mechanical and manufacturing engineering. Some students, if they don't for example, perform on the project or they don't do the project, they can come out with 60 credits, and that effectively can you can graduate with a graduate diploma at that point in mechanical manufacturing engineering from DCU. And then other students can decide that, look, a master's not for me. I want to do maybe just a number of modules, or you had trouble through the year that you couldn't pass modules, and so some of those students, we can exit them with 30 credits, and you would get a graduate certificate. And we also have the just from the perspective of inwards points of view, we do have capability that students come into DCU to actually do a graduate certificate, a graduate diploma, and then building that up to a master's as well. But from your perspective, coming as masters, these are exit awards if you plan so or if you don't plan so. So I just want to briefly talk about access. It may not affect you, considering most of you are mechanical and manufacturing engineering students, and you should be able to apply for the program directly. But if you do have a lower grade in your mechanical or manufacturing engineering undergraduate degree, then we'd kind of maybe just suggest that you do the access course. And the access course, who do not have a primary degree in mechanical engineering, 30 credits, 6 six level, 8 modules, must pass each module 50%, no carryover to mechanical engineering. Um, so this is basically do not have a primary degree to access is. Um, so these modules end up being maths, manufacturing, mechanics, maths, mechanics, and fluids. So these are kind of very base modules that we would expect that if you don't have a degree in mechanical engineering, that you probably wouldn't have done these modules in most other programs, even science, physics, etc. Don't may not do these modules. And therefore we want you to bring you up to the mechanical engineering level. We want you to pass comfortably, and that's why we want you to pass at 50%. And then you'd the next year after you'd qualify into the mechanical engineering master's program with ease. The other option was the master's qualifier, and this was the one that's basically if you don't have enough high enough mechanical and manufacturing engineering qualification, that you do just do a few more modules to make sure that you do get to that high level that we want, so that you can actually pass our master's program. And again, this pass rate for these modules is 50%. Um, and so basically the modules are oops, sorry. Sorry, I'm just having knocking off that. Just give me 1 second. But the master's qualifier course is allows you to back to it here. Okay, so hopefully you can see my screen there. The master's qualifier is a number of credits. You could do it um uh you could do it part-time or full-time. And again, these modules allow you to basically build up your capability as a within the knowledge around mechanical engineering, so that you can the year after then you can actually qualify into mechanical engineering. And again, the pass rate is 50%, and we'd expect students to pass that, so they can actually come in and do the mechanical engineering degree with without any trouble, basically. So that's kind of I'm going to end those slides there, and but that's my presentation. So if there's any questions, I'm happy to take them.